Dear friends, last class I explained what is algebraic and transcendental equation, and we discussed the two problems on Newton-Raphson method, how to find a solution for a given algebraic equation. Today we are going to discuss about non-algebraic equation. The working procedure will remain the same. Okay. Now first, we'll take an example of 3x minus cos x is equal to 1 and 4 decimal places. As usual, first consider the given function f of x is equal to 3x minus cos x minus 1 and find out its derivative. 3x derivative is 3 and cos x will become sin x. Remember, the difference in the algebraic and non-algebraic equation problems is when the equation involve trigonometric function. That's why we call this one as non-algebraic equation. In this case, we need to convert the calculator in a radian mode before solving the problem. So first convert the calculator in a radian mode when you have a trigonometric functions in the given equation. So after converting, proceed the problem. First, we'll replace x by 0. When you replace x by 0, I got the negative value. Next, we'll go for f of 1. I got the positive value. So this is enough. I need opposite sign, so one is negative, another one is positive. Therefore, x lies between 0 and 1. And if I compare these two values, f of 1 is nearer to 0. Therefore, x naught is 1. Now using this x naught and Newton-Raphson method formula, we'll need to find out the iterative value of x. First consider the initial value of x. Using this, find out f of x and f dash of x. Use this value in the Newton-Raphson method. We got the first iterative value as 0.6200. Now update the value of x by the first iterative value. That is, consider x as 0.6200. Using this new value of x, find out f of x and f dash of x. Now in the second iteration, I will get the x value as 0.6071. The first and second iterative values are not equal, so we'll repeat the procedure by using x as 0.6071. Using this, find out f of 0 and f dash again. And the third iterative is 0.6071. Now here the second and the third iterative values are equal, so this gives your final answer. Okay, the difference is here we have a trigonometric functions, that's why we need to consider the calculator in a radian mode. This is compulsory. Now we'll go for one more example, that is also transcendental equation. That is find a root of log x is equal to cos x. Here decimal place is not mentioned. Remember, in a numerical method, in the statement, if the decimal places is not mentioned, fix the calculator for 4 decimal places. Now once again in the problem we have a trigonometric function, so calculator should be in a radian mode. And here another difference in this particular problem is log x. When you have a log x, we won't start from f of 0, because when you replace x by 0, you will get log 0. And we know that log 0 is not defined. So no use of f of 0. So I will start from x is equal to 1. So replace x by 1, we received negative value. Replace x by 2, we received positive. So I have one negative and one positive. Therefore x lies between 1 comma 2. And in these two, f of 1 is nearer to 0. Therefore x naught is 1. Now using this x naught is equal to 1 and use the Newton-Raphson iterative formula as usual in the table, find out the iterative value of x. So x naught is 1, use this in f of x and f dash of x and substitute this value in the Newton-Raphson iteration formula. Will receive the first iteration as 1.2934. Now update this value here and use this to find out f of x, f dash of x. Substitute everything in the formula. The second iteration as 1.303. So these two are not equal, so repeat the procedure. In the third iteration we got 1.303. So the second and the third iterative values are equal. So this is my final answer. Now the difference in the next problem. Observe the equation x cube minus 4x plus 9. This is just an algebraic equation, but the problem, I want to find a negative root, not the positive root. So root, that may be any real number, -1 plus 1 minus 2 plus 2. The root means minus infinity to plus infinity. So in this type of problem, first consider f of x and find out its derivative. First replace x by 0. After replacing x by 0, we need to find out negative root. So we'll replace x by -1, -2, -3, -4, -5, like that. Not by 1, 2, 3. Now here, I want to find a negative root. That's why I'm replacing x by negative values. When you replace x by 0, positive. Now next, when you replace x by -1, again a positive. I want opposite sign. So replace x by -2, again a positive. So one more value, replace x by -3. Here we have a opposite sign. In the first three value we received positive values 9, 12, 9. But when you replace x by -3 we received negative. So x lies between -2 and -3. Therefore x0 is 3 because f of 3 is nearer to 0. This is nearer to 0 when you compare f of -2. Now the remaining procedure as it is. There is no difference in the procedure. Substitute the updated values in the formula and continue the procedure until the two iterative values of x should be equal. So here the third and fourth iterative values are equal. So that is your final answer, minus 2.7065. Now this is the working procedure of Newton-Raphson method. Here I explained 5 problems. For your practice, here I am giving around 6 to 7 problems. Work out these 6 to 7 problems. Observe the first problem. We need to find the root for a tan x minus 1.5x is equal to 0. Correct to 4 decimal places. X lies between 0.9 and 1. Means he given the location. X lies between a 0.9 and 1. You need to find out which one is x0. That may be 0.9 or 1. There is no difference in the problem number 7 and problem number 8. We need to consider in a radian mode because sin x we have. And in problem number 9, here we need to find the derivative of 10 power x. The derivative of 10 power x is the derivative of 10 power x is 10 power x into log 10. Okay, so use this derivative here in this problem and the remaining working procedure is as it is. And there is no difference in the problem number 10. But problem number 11 and 12, we have a derivative of log x to the base 10. So log x to the base 10, we know the derivative of log x. The derivative of log x is 1 over x if it is log x to the base e. But the derivative here, we have a log x to the base 10, not for a log x to the base e. So to find the derivative of log x to the base 10, we need to convert this into natural log first. That is log x by log 10. Okay. After converting, we know the derivative of log x and we need to find the log 10 value. So the log 10 value is 0.43, that is 1 by log 10 we have. That 1 by log 10 is a constant term. We'll consider outside the derivative. And 1 by natural log 10 value is 0.4342 divided by, and the log x differentiation is 1 over x. Okay. So this is the procedure of Newton-Raphson iterative method. Here I gave some examples and around 6 to 7 problems for your practice. So find the solution for this problem. If you are not finding the solution, if you are facing a problem to find a solution for this problem, in the next class I will send the notes of this and I will mention the answers also. Thank you. In the next class we'll continue the procedure of, I will explain the working procedure of regular falsy iterative method. So this completes your Newton-Raphson iterative method. If you have any doubt, you can contact me through message or through call. Thank you.